All right, welcome to this explainer. Today, we're going to tackle a concept that might literally flip the way you view our place in the universe upside down. We are talking about the Silurian Hypothesis. Proposed back in 2019 by scientists Gavin, Schmidt, and Adam Frank, this hypothesis is designed to immediately challenge a core belief that pretty much all of us hold. You know, the one that we, humanity, are the absolute peak of biological evolution and the very first and only intelligent, advanced civilization to ever exist on planet Earth. But what if our obsession with searching for advanced life out there in space is blinding us to our own planet's deep, hidden history?
Okay, let's dive into this because exploring this idea requires a massive perspective shift. I want you to truly imagine, just for a second, if past ancient civilizations were just as advanced as us. And I don't mean just banging stone tools together or building basic mud structures. What if there were beings millions of years ago driving vehicles, generating power, and creating synthetic materials? We are always looking up to the stars for advanced exoplanets, but this hypothesis forces us to look right beneath our feet. Would we even know if someone else was here first?
To answer that, we kind of have to frame this narrative as a cosmic detective story. Let's run a quick thought experiment. Imagine a complete cosmic disappearing act. What would happen if a massive cataclysm, maybe a pandemic or a natural disaster, just wiped us out completely tomorrow? Fast forward 100 to 200 million years from now, if future archaeologists, maybe a completely different intelligent species, tried to dig up our legacy among a crumbling ancient city, what would they actually find? You might think our towering skyscrapers and massive infrastructure would leave an undeniable mark, right? Well, let's look at the actual math of deep time. Consider the sheer scale we're dealing with. The Earth is roughly 4.5 billion years old. Now, look at how microscopic our sliver of existence really is. We have only been present on this planet for about 3 million years. When you contrast our existence against the vast, almost incomprehensible geological timescale of our planet, we are barely a footnote.
And it gets even more humbling. Just think about the number 300. Out of our already tiny 3 million year history, our era of true technological advancement, the age of heavy complex machinery, mass industrialization, and all those non-biodegradable plastic forks we use once and toss out, has only existed for 300 years, just 3 centuries. In the context of deep geological time, 300 years isn't even a blink of an eye. It is literally a fraction of a millisecond. And this brilliantly illustrates another major problem for any future archaeologists. Looking at our physical footprint, despite our population nearing 8 billion, we have only heavily modified about 14.6% of the Earth's land with our infrastructure and agriculture. That's roughly 18.5 million square kilometers, which is just slightly bigger than the landmass of Russia. The vast majority of the planet is totally unmodified. This means our concrete megastructures, along with our brittle organic fossils like bones and teeth, simply will not easily survive 100 or 200 million years of brutal tectonic plate shifts, erosion, and decay. So if our buildings crumble to dust and our bones completely disappear, what on earth is left? Well, any direct physical evidence of our existence is going to be compressed by the immense weight of time into a few, highly unremarkable centimeters of rock and soil. To a future civilization, those few centimeters might go completely unnoticed. Therefore, future scientists won't be looking for physical objects at all. They will have to act like forensic detectives hunting for indirect chemical footprints left behind by our industrial activities.
Now, what's really interesting about this is the specific chemical contrast we leave behind. Since the mid-18th century, humans have burned and released about half a ton of buried fossil fuels into the atmosphere and oceans. And this leaves a permanent chemical marker. You see, the Earth periodically warms naturally due to things like volcanic eruptions, which release greenhouse gases containing a heavier carbon isotope called C13. However, living organisms prefer to absorb a lighter isotope, C12. Because fossil fuels are literally made of ancient dead plants and animals, burning them floods the atmosphere with that lighter C12. Future geologists are going to see this massive, sudden spike in C12 and know for a fact it wasn't just a normal volcano.
But carbon isn't our only footprint. This brings us to 2 vital concepts, hypoxia and anoxia. Today, humans use massive amounts of artificial agricultural fertilizers packed with nitrogen. When it rains, this excess nitrogen leaks into coastal waters, causing a massive spike in microbial activity. These microbes and fungi multiply so rapidly that they consume absolutely all the dissolved oxygen in the water. This creates areas with low oxygen, hypoxia, or zero oxygen, anoxia.
We call these dead zones, and the Gulf of Mexico is currently a prime example of this human-driven phenomenon. Now, while dead zones are terrible for our current ecosystem, they are actually incredibly vital for preserving history. Because there is no oxygen in the water, animals that normally live in the ocean floor, like worms and burrowing creatures, cannot survive there. This completely halts a natural process called bioturbation, which is just a fancy word for animals burrowing and mixing up the soil layers. Without bioturbation, the layers of sediment settling on the ocean floor are perfectly sealed and preserved, sitting completely undisturbed for millions of years. And what exactly is getting trapped in those perfectly sealed anoxic layers? We are leaving behind a very specific, totally unnatural signature. We're talking non-naturally occurring synthetics, like chlorofluorocarbons, or CFCs. We're leaving highly concentrated pockets of mined rare metals, like gold, nickel, and platinum. And most remarkably, we're leaving lab-created radioactive elements like plutonium-244 and curium-247. Finding these dispersed in a single, distinct layer of rock is a permanent, entirely unnatural marker of an advanced civilization. Let's move on and see how this builds into a concrete framework. We've talked about carbon, dead zones, and synthetic elements. Now we're going to consolidate these chemical footprints into a highly specific, four-step methodology that future scientists would actually use to discover us. This right here is the rule of four, the exact scientific parameters required to definitively prove the existence of an ancient industrialized society hidden deep in the soil. First, a sudden drop in heavier C13 compared to a spike in lighter C12, indicating fossil fuels. Second, a shift in oxygen isotopes, specifically O18 replacing O16 in oceanic calcium carbonate, which is a direct marker of rapid global warming. Third, clear evidence of water body anoxia, those dead zones we just discussed. And fourth, the sudden presence of rare or synthetic elements in that exact same soil layer. If you find all four, boom, you've found an industrialization. Now, Adam Frank and Gavin Schmidt originally presented this just as a thought experiment to test our own archaeological methods. But here is where this explainer takes a truly mind-bending turn. What if we pivot this thought experiment backwards? What if we apply these exact four detective clues to a fascinating, real-world geological anomaly deep in Earth's past? Consider the data from about 56 million years ago. The Earth went through something called the Paleocene Eocene thermal maximum, or PETM. Global temperatures drastically spiked by 5 to 7 degrees Celsius in just 5,000 years, which is a flash in geological time. The conventional scientific explanation points to massive North Atlantic volcanic eruptions burning through buried carbon. But look closely at the data. During this exact time, we see a massive spike in the lighter C12 carbon. We see unusually high concentrations of heavy metals in the sedimentary layers, and simultaneously, we see a rapid, seemingly sudden spread of mammals right across the North American continent. As scientists analyzing this era have noted, there are still a lot of things that are not adding up. The rapid migration and spread of land mammals perfectly mirrors the way human populations spread during industrialization. And those highly specific chemical markers, the C12 carbon and the heavy metals, well, they perfectly mirror the rule of four clues of our very own industrial civilization. A purely natural volcanic explanation for the PETM anomaly starts to feel just a little bit incomplete when you look at it through the lens of the Silurian hypothesis. So I want to leave you with this final provocative thought. Is this all just a massive, natural coincidence, or are we looking at the echoes of an ancient civilization? Think about our own legacy. Are the anomalies of 56 million years ago just natural flukes of a changing planet? Or are we literally walking on the dust of a species that drove cars, built cities, and caused their very own climate crisis millions of years before the first human even took a breath? The Earth's soil holds the answers, and it forces us to be deeply humbled about our own permanence in the grand sweeping mystery of deep time.